Hi everyone, in this video I'm continuing to look at question 13 part C of the 2020 North Sydney Boys Extension 2 trial exam. So here I'm up to question part 3, which wants us to find the sum of the area of the shaded region in the diagram below. And here we've got these rectangles that sit above the curve. In prior videos I've already worked through the case where n is an even number. And we did that by first looking at n is equal to 4 as a specific example, and then we generalized to get a general result for even values of n. Now we need to think of the other case where n is an odd number. And to kick that off, we're going to start by looking at the specific case where n is equal to 5, and then in a follow-up video we'll try and generalize that result. So yeah, let's take a look. So here I've got our curve, and we want to look at the specific case of n is equal to 5 and then see if we can work out the pattern of what's going on. If I wanted to divide this range 0 to 2 into 5 bits, so we've got, it's essentially 8 centimeters on my ruler. So if I did 8 divided by 5, I'm going up in 1.6. So let's just get another color. So we'll go 1.6, 3.2, 4.8, 6.4, that should do it. Up, 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 and up. And so what are we going to have here? We're going to have this rectangle here. We'll have this rectangle here. We'll have this rectangle here, and we'll have this rectangle here. And then the interesting thing is when we've got an odd number like 5, we've kind of got this gap in the middle where we've got the curve at the midpoint, which adds an extra rectangle that kind of straddles the midpoint of this range. So that's something different that we didn't see when we were dealing with an even number. So let's see what we get and then how we can then think about generalizing that. So as usual, we want to get the area of this these shaded rectangles. We know the width of the rectangles will be 2 on 5 because we've divided this range into 5 equal bits. And then we just want to think about the heights of each of these rectangles. With reference to our function, the function is y is equal to the square root of x2 minus x. And yeah, just like we have in the past, for this example we can calculate the exact value, and then that'll form a check for when we try and generalize, which I'll do in a follow-up video. So for now, let's think about this one. The area will be equal to the width of the rectangle times the height, which will be the function at 2 on 5, plus the same width times the function at 4 on 5, plus the same width times the function at, and this is the interesting one where it's actually the function at 1. So we haven't jumped up 2, 4, 6. We kind of have this function at 1 in between, and then we're going to get our next one, which is 2 on 5 times the function at 6 on 5. And then finally this one here, 2 on 5 times the function at 8 on 5. So again, thinking in terms of our general pattern, we'll go 2, 4, 6, 8. And so this bit here in the middle is the bit that makes sense to kind of throw out to the end so we can then get our summation. So I might just write that in that format here so that it helps give you a bit of a hint as to how we're going to generalize it in the next video. So I'll factor out all these 2 on 5s. So we'll have f of 2 on 5 plus f of 4 on 5 plus f of 6 on 5 plus f of 8 on 5. That's all being multiplied by 2 on 5, and then we've got this extra plus 2 on 5 times f of 1 at the end. So in terms of throwing that into our function, it'll be 2 on 5 times the square root of 2 on 5, 2 minus 2 on 5, plus the square root of 4 on 5, 2 minus 4 on 5, plus the square root of 6 on 5, 2 minus 6 on 5, plus the square root of 8 on 5, 2 minus 8 on 5. And then off to the end, plus the 2 on 5 times f of 1 is the square root of 1 times 2 minus 1. Square root of 1, which is just 1, so that can just stay there as plus 2 on 5. So if I simplify these square roots, we'll get 2 on 5 times, let's key this in, 2 on 5 times 2 minus 2 on 5. So that's square root of 16 on 25, which is really just 4 on 5. And then 4 on 5 times 2 minus 4 on 5. It's the square root of 24 on the square root of 25, which is just 5. Now we should get symmetry. Let's just double check. 6 on 5 times 2 minus 6 on 5. Yep, square root of 24 on 5 plus 8 on 5 times 2 minus 8 on 5. So that's, yeah, square root of 16 on 25, which would be 4 on 5. And then plus the 2 on 5 at the end. So now I'm just going to key this into my calculator, see what we get, and that'll form our check for our next video. So I'll do the square root of 24 divided by 5 plus 4 on 5. So that's these two. And now we've got two of them. So times 2 times 2 on 5. And then plus 2 on 5 at the end. So that's going to get us 1.8. 2, 3, 8, 3, 6, 7, 1, 8, and so on. And so this is what we're going to use to check when we try and generalize the formula. We can throw in n is equal to 5, see if we get the same result. Panic boom! So yeah, that's what I'm going to do in the next video. So yeah, see you in the next video.